In example 4, a function value and quadrant are given. Find the values of the other 5 trigonometric functions give exact values. Cool. Sine of alpha is equal to negative 1 over 3. It's in quadrant 3. So I've got some kind of angle in quadrant 3. I'm just going to draw anything right now in quadrant 3. And I know that its sine is, so this is my angle, and this is my reference triangle. So my reference triangle I can highlight real quick. My reference triangle is over here. And I know that the sine of this angle, this is alpha, is going to be opposite over hypotenuse, negative 1 over 3. So this needs to be negative 1, this needs to be 3. I know that the negative is attached to the opposite side, not to the 3, because 3 could never be negative as a radius value. Now, we want to find the value for the adjacent side. So let's call it A. And we'll say A squared plus negative 1 squared equals 3 squared. So A squared plus 1 equals 9. A squared equals 8. So that means that A is positive or negative square root of 8, or positive or negative 2 square root of 2. Now, I have to select the appropriate sign right now for A. Because I am in quadrant 3, I meant to say, I'm on this side. Because I'm on this side, I know the x values are negative, so we're going to select the negative. We know that A could not be positive on the left side of the x-axis. So our A value in this situation is negative 2 square root of 2. It's not both. I have to choose which one is appropriate based on the quadrant I'm in. So this A value is negative 2 square root of 2. Now that I have all 3 measures, I can write down all of the measures, all of the trigonometric ratios. So I started, even though they already told me, I'm going to write down sine of alpha equals negative 1/3, just because it helps me to get secant, cosecant, those kind of things. So cosine alpha is equal to tan alpha equals to, we'll find those 3 first. I already know the first one. Cosine adjacent over hypotenuse is going to be negative 2 square root of 2 over 3. And then tangent, opposite over adjacent, those 2 negatives are going to cancel. I'll write the negatives first. I get negative 1 over negative 2 square root of 2. I got to rationalize this thing anyway. So the 2 negatives cancel, and I have square root of 2 over 4, or no, that's already simplified. Good. I thought I was going to simplify it, but I simplified it already. So the 2 negatives cancel. This square root of 2 multiplied up, and then 2 times 2 in the bottom is 4. Perfect. All right. And then the other 3. So cosecant alpha, secant alpha, and cotan alpha. So 3 over 1, that's going to be negative 3. This is going to be negative 3 over 2 square root of 2, which simplifies into, when I rationalize that, that's going to be negative 3 square root of 2 over 4. And then if I flip this original, it's going to be positive 2 square root of 2 over 1, which you don't write. And now we have all 6 of them. We found the other 5, we knew the first one, found all 6 of our trig ratios. All right, looking at special cases. Special cases are where we have a terminal side that is on an axis. So if the terminal side is right on the y-axis, we know that the initial side was on the x-axis, then our angle is 90 degrees. If our terminal side is on the other x-axis, then our angle is 180 degrees. If our terminal side is on the negative y-axis, then our angle is 270 degrees or negative 90 degrees, depending on how you're representing it. And if our terminal angle is back all the way around in the positive x-axis, our angle is 360 degrees or 0 degrees, depending on how you're representing it. Those are coterminal of each other, so there are 2 ways that we commonly represent those. All right. Now, we do tend to talk about things in terms of positive angles, so we're going to make a chart here for the positive angles 0, 30, 45, 60, 90, 180, 270, 360. We have already done this for the angles 30, 45, and 60. These we can find in our previous chart. We're not doing anything new to create those. They are the same things that we've done before. What's going to be new is that we're going to be listing also in this chart, completing the chart, listing trigonometric ratios for the other 4 angles. Now there are 5 there. I only said 4 because remember that these two are coterminal. These two columns are going to be exactly the same. So there are really only 4 angles since these 2 angles are the same angle. All right. So let's fill in our 30, 45, and 60 first because we already know them. I'm going to start with 45 because I have these ones memorized. I know the sine of 45 is square root of 2 divided by 2, and the cosine is also square root of 2 divided by 2. That means that the tangent is 1. The cosecant is the square root of 2, the secant is the square root of 2, and the cotangent is 1. Okay. You may want to look back to the other ones to refer to them if you don't have them memorized yet. I'm going to fill in the rest of them. The sine of the 30-degree angle, remember the 30-degree angle was the angle that is shorter, 60 degrees taller, so if it's shorter it's going to have a smaller y value, so that's going to be 1/2. The cosine is the square root of 3 over 2. That's the reverse in the 60 degree. In the 60 degree, the sine is the square root of 3 over 2, and the cosine is the 1/2. Now the tangent is the ratio of those two. So if I take sine divided by cosine, that's going to be 1 over the square root of 3, or square root of 3 over 3. And if I do it in reverse, if I do the tangent of the 60, that's going to be the square root of 3. I remember that these are reciprocals of each other, so I can do the cosecant, secant, and cotangent. So first of all, the cosecant, that's the reciprocal of 1/2, so that's 2. The reciprocal of 2 over the square root of 3 is going to be 2 square root of 3 over 3. And then the reciprocal of square root of 3 over 3 is going to be square root of 3. Then for cosecant, these are cofunctions, so this is going to be 2 square root of 3 over 3, 2, and square root of 3 over 3. Okay, that table should match exactly the table that we had in our first section of this chapter. Go back and look at it to make sure. Now we're going to fill in the rest of them. Sine of 0. Okay, the sine of 0 is, remember the sine is the opposite, the height of your triangle. This is the y value. This triangle does not have any height. Its height is 0. The sine of 0 is 0. That's also true of the sine of 360 since they're coterminal angles. Now the cosine of this angle, it's got a terminal point at 1 right here. So its x value is 1, and that's the adjacent side. If I divide by the hypotenuse is the same thing. That's 1 divided by 1. That's 1. Okay, tangent. Tangent is the opposite, which is 0, divided by the adjacent, which is 1. So that's, again, 0. I'm filling in both of them at the same time because 0 and 360 are coterminal. Cosecant. This would be the reciprocal of sine. Since sine is 0, 1 divided by 0 is undefined. So it's undefined. It does not have a value. Secant. Reciprocal of 1. 1 divided by 1 is 1. Cotangent. 1 divided by 0 again is undefined. Okay. 90 degrees. All right, so 90 degrees. In this case, the triangle has no adjacent side. It has height, but it does not have width. So its opposite side has a height of 1. So 1 over 1 is 1. But its adjacent side, there's no triangle there. The triangle is just, sorry, covering things up. The triangle is just that flat line right there. So there's no width to that triangle. It has no adjacent side, so it's going to be 0. Okay. The tangent, which is the opposite side divided by the adjacent side is going to be undefined. And then the cosecant is 1 divided by 1. Then the secant, 1 divided by 0, that's undefined. And then the cotangent. I can't take the reciprocal of undefined, but if I flip this ratio, instead of 1 divided by 0, it's 0 divided by 1, so the cotangent is going to be 0. All right. now that I've done 90, I'm going to just jump over to 270, because 90 and 270 have very similar properties, except the 1 isn't positive, it's negative. So we're going to flip this one to -1, 0, undefined, -1, undefined, and 0. And with that in mind, the 180 was the opposite of the 0 and the 360. So if I forgot to fill in the bottom for 360, I will do that in a second, but if I flip what I did for 0 to make the 1's negative, I'll have a table for the 180s. So 0, -1, 0, undefined, -1, undefined. Oops, this one's positive. Okay, and then I've got my undefines. All right. There are some nice patterns within the values of the trigonometric functions. Some of the patterns include that if I know how to handle up through 90, then the other ones are all going to follow suit. So if I just know quadrant 1, 0 to 90, I know the rest because I just need to flip the negatives. This is also true. That's why I don't write down things for, say, 120 degrees, because that's a 30-degree angle in quadrant 2. Okay, so if I know, I'm going to highlight, if I know 0 to 90, the theory is that I can figure out the rest. Okay, can figure out any, oops, started writing 2 words here, any coterminal of these based on knowing 0 to 90 and reference angles. What I really meant besides coterminal, and this says any, it's a little hard to read, sorry, any. I can figure out any, I meant to say reference angle. I restated it later on. I can figure out any reference angle, or coterminal of course, but reference angles are the ones I was trying to talk about, based on the knowing 90, 0 to 90.